Hi there. So in this series of videos, we're going to be going through the process of setting up a mill turn machine using either the OSD file format, which is ENCY's internal CAD file format. In the prerequisite video, we'll have gone through the differences in different file formats and different geometry acquisition methods for this process. So to start with, we're going to import the necessary files, and we're going to do so by clicking on Add Mechanism and Lathe Milling Machine. As you can see here, I've got the program set up to build a lathe milling machine as opposed to the more frequently seen robotic milling cell or whatever. So I click on here, and in this folder that we've got set up here, I am going to grab the lathe base, tailstock, x-axis and z-axis, and open those. And as we can see, it's imported the bulk of the machine in one go. So we're now going to assign the joints on this. We're going to stick with the ZX turrets and B tailstock template because that one works for this machine quite nicely. So we'll define this as our base. We will define axis Z and axis X and the tailstock accordingly. Now we'll go into the kinematics section and define the various axial limits as well as the connection points as well. It's important to do this now because otherwise you will have a much less fun time setting up the chuck and the tool turret. So we do this by holding down Control and selecting the base of the chuck there, for example, and we can see how we get a slight orange highlight there, which defines the edge that it's trying to anchor to. So we want it here, and that means that our lathe chuck is in the correct place. And for the tool turret, we're going to do the same. So hold down Control, grab that, and again we want that orange highlight to be at the outer arc of the cylinder that we're centralizing this on. So those are now defined, which is great, and we are now going to define the travel ranges for each of these axes. So to do so, I'm going to click on axis Z here, and the limits are what we're going to be defining. So this, for example, we're not going to be having it running a meter off beyond the end of the bed. So I'm going to set the maximum to 0. And I'm going to set the minimum to, I think it's about -700, that one. Which, it's a little bit much, but let's go with -600 just to be safe. Yeah. Okay. And we're going to do the same for the x-axis. Notice how I'm not clicking apply here because that will close this tab and we'd have to reopen it and go through all this again. So the x-axis, this will only travel -150 and +0 because it's currently in the 0 position. And the tailstock will travel -600 to 0. Now that we've defined all of those, we can quickly check in the simulation that we're happy with those ranges of motion. So that seems pretty good to me so far. We can probably afford to let the turret move a bit further forward, judging by the length of the rails, but 600 will suffice for now. In the next video, we're going to take a look at how to include and set up a 3-jaw chuck for this machine, including defining and limiting the range of motion for the chuck jaws as well. So I shall see you then.